Hey all my dear students, welcome back again to H.S.P in World of Chemistry. Right now, I will tell you one simple fundamental thing that is going to solve near about 4 chapters questions. Now see, let's start with, you can call it Nandu and call him to be Hassu. There are two type of people, Nandu and Hassu. As you can see, Nandu is weaker and Hassu is double, means powerful. Hassu is more powerful. Now how to find out that Hassu is more powerful? Because here to have drawn the diagram, but in the examination you have to deal only with chemicals. So once you can correlate the chemicals with person, with whole everyday life you can talk about, then definitely the question paper you can solve, the chemistry you will start loving chemistry. Right now see, Hassu is double power because Hassu is H2SO4 and H2SO4 can release, you see how many H plus ions, 2 H plus ions. So its power, N factor we call power is 2, N factor is power, and it can release just one OH negative ion, so its N factor is 1. So what we are getting, remember in your brain that N factor is the power. Let me write down here, your N factor is equivalent to power. And now you see his power is double and his power is single. If they want to equal fight, this is basic army and this is acidic army, this is hero, this is villain. If you want that fight should be equal, that no one is going to win or they will remain on same position. So see, if I say it's 1 mole people are there, 1 mole in his army, basic army, 1 mole people, and if I say in this army also there are 1 mole, so who will be winner? Definitely he is going to win this game because his 1 mole army can kill his 2 mole army person, right? So definitely, if you know why I'm saying, because his power is double than that, he is heavier than that, he is more powerful than that. So if you really want to make this fight to be equal, so make it into 1 into 2 moles. So 2 moles, because 1 mole will kill its 2 moles. Now you know this is the fight, we have easily solved it, but by chance if it is coming in the chemistry, we won't be able to solve anything. Oh my god, what's happening, kya ho raha hai ye, what's going on, hum kuch bhi aankhon ke samne andhera cha jayega. So let's see in the chemistry how to do that. Now by fight, 2 mole of this person and 1 mole of this person, all they will fight together and they will convert into another type of people, that salt and water. Now see the chemistry. If I say its power is 1, so just remember N is number of mole of people and NF is power. NF is power, number of moles of people, and this is the power. So what is the thumbnail? What was written on the thumbnail? PP rule. People, power, PP rule. Just remember one thing, number of peoples and the power, PP rule. That you have to put it in your brain, PP. P for people, P for power. Now see, if I say NNF, NNF of acid or base is equal to NNF of acid. This is known as law of chemical equivalence, law of LOCE. What I'm saying, law of chemical equivalence. Now see, my dear students, if one thing is given, suppose about this is given 1 mole, its 1 mole is given and its power we are getting from here, and its 1 mole is given, then we can find out the power, or power is given, we can find out its mole. If its moles are missing, we will say 2 into 1. If I write here n moles, so you see 2 into 1, 2, and n into 1. So n is equal to 2. So its 2 moles will be required. Is it clear? First of all, tell me. If power is less, more people will be required. If power is more, less people will be required, and this law is valid everywhere. You must have seen N1 V1 is equal to N2 V2. If I talk about gaseous law, then P1 V1 is equal to P2 V2. If something is constant everywhere, I have written just 4 chapters. My dear student, I can kill 8 chapters with one simple rule, PP rule, power and number of people. Now see, first question in front of you. Just see this question. Is it visible to all of you? That it's written N2 plus 3 times H2 gives 2 moles of ammonia. Read it out. Everyone, just read it out. Then I will explain. Then Baba will explain to you. First, everyone read it out. Haber's process. This is from Chemical Kinetics chapter. Chemical Kinetics. Now see what they are asking. The rate of reaction and rate of disappearance of H2 will be. And what is given? About ammonia is given. This is the concentration, moles per liter. Now you will say, sir, how to apply PP rule? Because there you said number of people and N factor. Here, number of people are not given. So remember that number of moles per unit volume. Concentration is nothing, number of moles per unit volume, and this reaction is taking place in the same flask, so volume will remain same. So if volume is same, then number of moles and concentration is same. Now just see from here what you can see, that rate of appearance of ammonia is given this much, and they are asking rate of disappearance of H2. That means they are comparing in between H2 and ammonia. If you see the previous one, if I say its N factor was 1, its N factor was 2, when N factor was X raised to Y crisscross, molar ratio will be Y raised to S. If N factor is X raised to Y, molar ratio will be Y raised to X. Remember that. If N factor you know, you can balance the reaction. This is the next application. If balance reaction you know, you can find out the N factor crisscross. If balanced reaction stoichiometric coefficient is 2 raised to 1, then N factor will be 1 raised to 2. Its stoichiometric coefficient, its power, its stoichiometric coefficient, its power, right? Now see. So you see, if I say their N factor, if its stoichiometric coefficient is 2, its N factor will be 2, and if its stoichiometric coefficient is 3, that should be its what? N factor. So can I write here that twice of, no, don't let us write it N factor. So here is H2 and here is ammonia. Now I will say number of moles, that is a concentration per unit volume, number of moles, that's number of moles will become concentration will become number of moles, and its N factor is 2, and its number of moles and its N factor will be 3, right? This thing you are able to understand, and I will put equilibrium sign is equal to, because N1 F1, that is N factor, N is equal to NN, right? Now see what information we are getting. Ammonia is given 2.4, its moles per liter, that is the concentration. We can write here 2.1 into 10 raised to power minus 4 into 3 is equal to, this 2 we know, this we don't know, so I can write N is equal to and divide it by 2. Now see, 2.53s are 7.5, and 7.5 into 10 raised to power minus 4, 7.5 into 10 raised to power minus 4 divided by 2. Now what I will get? 275. 75's half is, if I say 74, that is 37.25. So it will become 3.75. Say 3.75. Yeah, 3.75 into 10 raised to power minus 4. Now 3.75 into 10 raised to power minus 4. So this is wrong. This is wrong. In both of these, 3.75 into 10 to the power minus 4 is given. Why? Our work is solved. Now, if you really want to solve even this question also, the rate of reaction. The rate of reaction is always measured with one stoichiometric coefficient. So you can see its stoichiometric coefficient is half of it. So half of it, or you can directly write rate of reaction is equal to, this is the product 1 by 2 with the concentration of ammonia that was given. This concentration of ammonia I will write here. So I will write 1 by 2 into 2.5 into 10 raised to power minus 4. 10 raised to power minus 4. So you will definitely get half of 2.5 is 1.25. 1.25. So this will be your correct answer. I hope this is clear. This is clear. You can orally solve this question once you do the practice. I have taken this much of time because I wanted to tell you in detail. Now let's see. Second, the instantaneous rate. Once again, this question is from, you see, chemical kinetics. What it must be looking like redox reaction. Are you getting my point? Now see, the instantaneous rate of disappearance of MnO4 negative, pink, purple or red ion in the following reaction is this much. And what they are asking, the rate of appearance of I2. That means MnO4 negative, law of chemical equals, that is with I2. Now we know that its n into n factor will be equal to its n into n factor. Now what is given? We know that concentration, number of moles per unit volume. Volume is same, so concentration will be equal to number of moles. So about MnO4, but let me tell you, the balanced reaction is given, so no need to find out the n factor. Otherwise, n factor we must have calculated with the help of oxidation state, that MnO4 negative is changing into Mn2 plus. Its n factor is C. Let me tell you, its n factor is 5. And this I negative is changing into I2. Here it's not required because once the balanced chemical equation is given, no need of n factor. I've told you when n factor is x raised to y, molar ratio will be y raised to x. Now, but let me make it clear, if by chance they have not given the n factor or the balanced reaction, how to do it? I negative is changing to I2. So its n factor 1 I negative is changing to I2. So minus 1 to 0. Minus 1 to 0. Can you see what should be the n factor? N factor. So minus 1 to 0. So its n factor is coming 1. So if I write this is 5, then that should be how much? If this is 5, but see, this is the n factor of I negative, but we are supposed to calculate of I2 because in the question they have given I2. So that will not work. Let's calculate n factor of I2. I2 is changing into I negative. So n factor is equal to number of atoms into absolute mod of final oxidation state minus initial. So its n factor is 2. Its n factor is 2. So see, 5 and 2. So 2 and 5 matching or not? It's exactly matching. But here, because the balanced chemical equation was given, so no need to find out the n factor. Now let me write down. Its n factor is 2. Moles I don't know. Its n factor is 5. And moles are given the concentration 4.56. 4.56 into 10 raised to power minus 3 into 10 raised to power minus 3. And its n factor, moles I don't know, moles, the rate of appearance. So moles is not given. This is the n factor. So let me write down moles I don't know, n factor. Once again, let me tell you, moles and concentration we can take same because the volume is same. So only we have to find out n because n factor is 2. So let me write down here 2. So n will be equal to 4.56 into 10 raised to power minus 3 into 5 divided by 2. Now if you divide by 2, so this will become 2.56, 28 into 10 raised to power minus 3 into 5. Now 5 2s are 10. if I write something more than 10 into 10 raised power minus 3, something more than, so can I write 1 point something into 10 raised power minus 2? This is the answer, 1 into 10 raised power minus 2. 1 into 10 raised power minus 2. So fourth is the correct answer. Got it? Kids, is it working? Are you getting my point? Everyone, are you getting my point? Now, next question. By chance, if you're not able to understand anything, you can ask me in the comment section. Okay, now let's see another question. This is from mole concept. Mole concept. Just see to it. When 1 mole of SO3, 1 mole of SO3 and 1 mole of O2, 1 mole of O2 are made to react for completion. Now see, SO2 and O2, their power is not same. Directly you can apply unitary method. When balanced reaction is given, you can directly apply mole concept, but I will let you know NNF, Nana ki factory. So see, when 2 moles of this is required, it's 1 mole will be required. So what they are saying, 1 mole of SO3, 1 mole of SO3 is required, half mole of that will be required, but this is given 1 mole. So who is limiting reagent? 1 mole of O2 requires 2 moles of SO2. 1 mole of O2 requires 2 moles of, okay, 1 mole of SO3 and 1 mole of O2 are made to react. Something is wrong because it will not be SO3 because they are reacting. So here SO2 will be there. Correction. Sorry, misprinting is there. So 1 mole of O2 will require 2 moles of SO2, but only 1 mole of this is given. So this is your limiting reagent. One point is clear, and the product will be decided by limiting reagent only. Now you will say, sir, what happened to your NNF PP rule? You are doing it by unitary method. Has it got failed? No, my dear student. Let me tell you. If I tell you SO2 N into NF of SO2, right? N into NF of SO2, you see its stoichiometry is 2, its stoichiometry is 1. That means its N factor is 1 and its N factor is 2. When N factor is X raised to Y, molar ratio will be Y raised to X. So SO2's N factor is 1. So let me write down 1 and moles. Moles are given. SO2, 1 mole SO2 is given 1 into 1. It's coming out 1 milliequivalents. We will say 1 milliequivalents. Now let me write down O2 about O2. If I write down O2 NNF, N into NF, its 1 mole is given and N factor is 2. So it is coming out 2. Who is more? This is more and that is less. The less one is the limiting reagent. Less one is limiting reagent. I hope this point is clear. This is the limiting reagent, and limiting reagent is going to decide the product. Always the product is decided by limiting reagent. LR will decide product. So it's very clear from the mole concept. 2 mole of this, it's forming 2 mole of SO3. For 1 mole of this will form 1 mole of that. Hence very clear, right? Now you will say, what happened, sir? Once again you are doing it by unitary method. What happened to NNF? Okay, see PP rule. Everyone just see to it, PP rule. 2 and 2, that means N factor is same. 2, 2, N factor is same. So let me correlate SO2 and SO3. So it's people into power, people into power. So about whom we know about SO2 1, 1 into 2. I know power, I don't know N into 2. So the value N will come out 1. N will come out 1. So 1 mole of SO3 will get produced. And oxygen was in excess, so this is wrong. If this is wrong, so this is wrong. 1 mole of SO, because it was the limiting reagent. Limiting reagent will get consumed fully. That will not left. Now you see, is it clear to all of you? Once again, if it is clear, do let me know in the comment section that yes, sir, it's clear. Now next one. You see, this question is from mole concept. Nice slides. Nice slides. My speed is a little bit more because you are having less time. That's why I'm speaking very speedily, right? Now see, 1 mole of this army, 2 moles of this army, when they are getting died during fight, 1 mole of C is getting formed. 1 mole of this, 1 mole of is getting fight, then this is the stoichiometry ratio. So why you are telling us a stoichiometry ratio? Just do it with PP rule, people and power rule. Okay, I will do it. Now see, 5 mole of this, A and B. So it's, and stoichiometry is 1, it's 2, so its n factor will be 2 and its n factor will be 1. When stoichiometric coefficient is x raised to y, n factor will be y raised to x. If n factor is x raised to y, stoichiometric coefficient will be y raised to x. Crisscross. Now let's see A and let's see B. Its n into n factor people into power will be equal to its n into n factor. So what they are giving? Now first we have to find out who is the limiting reagent. How to find out limiting reagent? Let's see the limiting reagent. If I say A's n factor is 2 and they have given 5 mole of A, 5 into 2, and about this, right now we don't know whether they are equal or not equal. 1 into 8, this is coming out 8 only and that is coming out 10. So definitely this is more and that is less. Are you getting my point? This is coming out 10 and that is coming out 8. So definitely this is your limiting reagent. Limiting reagent will decide the product formed. This is going to decide. Now, if you are really having too much brain, you must be saying, why are you doing people and power rule? You directly will apply, because the reaction is balanced, just apply what? Unity method. That 1 mole of this are killing 2 moles of that. So 5 mole of this will kill 10 moles of that, but they are just 8. 1 mole of this army will kill 2 mole of this army. 5 mole of this army will just kill twice of that army, that 10 moles, but this is only 8 mole. So this is your limiting region. Now let's decide in between B and C. B and C, so that's gone and they are not equal. So this is the limiting region. B is the limiting region. So we will compare B with C. Now it's double, its n factor is 1, then in its n factor will be twice because you correlate this. Now what they are asking, this and this is reacting will produce what? Now see, let me tell you, with this to this, directly you can see 2 moles of this is producing 1 mole of that. So 8 mole of this will produce half of that, 4 moles of that. So answer is second, very clear. But let me tell you, people into power rule, through people into power rule, you can do it. Say about B and C, n into nf, n into nf. Now you must be thinking, sir, if we can solve it through unity method, why you are applying this n into nf? Because mole concept, unity method, somewhere it will work, some other place it will not work, but n into nf will work everywhere, my dear students. Whether the reaction is balanced or not balanced, this will always work. So always go with this. Now see, number of moles 8, n factor is 1, number of moles I don't know, n factor is 2. So the value of n will come 8 by 2. So n is equal to 8 divided by 2, that is 4. We are getting answer. I think one more question will be there. Let's see. Last but not the least, I hope everyone is able to understand each and everything. Now this is from Redox, a lovely Redox chapter. Let's see. How many moles of ferrous sulfate? I have told you now. I have told you. Now here reaction is not balanced, and that's why I'm telling you that 2 by PP rule. Power and people. Number of moles of people and power. Let's see. That KMnO4 in acidic medium. First of all, let me tell you about KMnO4 in acidic medium. Always remember that KMnO4, whether the medium is given or not given, if it is being acidic, form like this. If even the medium is not mentioned, always take it to be acidic, right? So see, from +7, it is getting changed to +2. So its n factor is 5. We got its n factor. Now let's go one by one. Ferrous sulfate. Ferrous can change to ferric. Ferrous can change to ferric. Green to yellow. Its n factor is coming out 1. Ferrous n factor is 1. So let's compare. KMnO4, let me write down here KMnO4, where to write down? Let me write down here KMnO4 and this ferrous NNF, it's N factor, it's N factor, and we know that how many moles of ferrous sulfate it is required by KMnO4, by 1 mole of KMnO4. So 1 into 5 is equal to, I don't know N, I know 1. So N is coming out 5. It has to start with 5. The first answer is 5. So this, oh my God, these can't be the answer. Only with 1 we are getting. But let me solve H2C2O4. H2C2O4. If I say H2C2O4, now they have not written. Now see, carbon is in +3 oxidation state. Maximum oxidation state of carbon is +4. So +3 to +4, but 2 atoms. So its n factor is 2 into absolute mod of 4 minus 3. That is coming out 2. So 2. Let me solve it over here for this what? This one. H2C2O4. So this is KMnO4. That is H2C2O4. N into n factor, PP rule, n into n factor. Its moles 1, n factor is 5. Its moles I don't know, n factor is 2. So the value of n will be equal to 5 by 2. 5 by 2. 5 by 2. It's written over here. Now let me solve for ferrous oxalate also. So in ferrous oxalate, 2 things are there. One is ferrous. Ferrous will convert from ferrous to ferric. So its n factor contribution is 1, and oxalate we already know its n factor because we have calculated over here. C2O4 2 negative is changing to carbon dioxide. Its n factor contribution is 2. So 2 plus 1, that is coming out 3. So overall its n factor is 3. So let me solve over here. KMnO4 into ferrous oxalate FeC2O4. So let me write down N into NF is equal to N into NF. Its moles given 1, n factor is 5. Its moles we don't know, n factor is 3. So n value will come out 5 by 3. 5 by 3, you see, 5 by 3. We have got the answer. So my dear students, I hope that you must have enjoyed this lecture. Write down in the comment section. I will bring number of such type of concept. Baba is having so many concepts that you can solve just the whole chemistry with few rules only. Okay, I said that only 4 chapters you can solve with this, but later on I will let you know that near about all the chapters of inorganic chemistry also you can apply, a number of other physical chemistry chapters you can apply this fundamental thing. Bye bye, take care, all the best.